Now, in this question, we have aqueous sulfurous acid, or H₂SO₃, and we have aqueous sodium chloride, and those are going to be formed by reacting this aqueous hydrochloric acid, or HCl, and this aqueous sodium sulfite, or Na₂SO₃. And what we want to do is we want to write down this chemical reaction and then balance it. And so what I'm going to do is I'm going to write down that I have H₂SO₃, and that's going to be aqueous. So I'm going to put a parentheses here, and then put AQ down for aqueous. And then I'm going to put a plus sign for what other chemical that's formed, and that's this aqueous sodium chloride. So I'm going to put down that we have NaCl, and that's also going to be aqueous, so it's going to get a parentheses and an AQ there. And because these right here, these chemicals there, those are going to be formed from this reaction. And so what I'm going to do is I'm going to put this arrow down here, and because these are on the right side, it means that these are going to be formed. And what's going to be reacted with is going to go on the left side. And what's on the left side is going to be this aqueous hydrochloric acid. So I'm going to put down that we have HCl. And then to show that it's aqueous, I'm going to put the parentheses and put an AQ down. And then we'll put a plus for the other reactant. And then I have this Na₂SO₃. And that's also going to be aqueous. So I'm going to put an AQ down. And what's over here, these are going to be called the reactants. So we have the reactants and the products are going to be also be formed. And so now that we got the reaction written down, we want to balance it. And so to balance it, we want to make sure that we have the same number of atoms on each side of this reaction. And so I want to count how many atoms I have over here and how many atoms I have over here of each different type. And so if I look right here, I have one H atom. And over here, I have two H atoms. So on this side, I have one H, and then over here, I have two H's. And so I need to get more H's to this side. So what I can do is I can add a whole new molecule of this right here. And so I can go from having a 1 molecule like this to having a 2 like this. And so if I have two of these molecules, I can do 2 times 1, and then I'll have 2 H's and not 1. So I have 2 H's over here and 2 H's over here. So now the H's are now balanced. And now what I'm going to do is I'm going to check the NAs. I have 2 NAs here, and I have 1 Na here. And so I need to get more NAs to this side. I have 1 Na over here and 2 NAs over here. So I need more over here. And so what I'm going to do is I can go from having a 1 of these molecules. So I have 1 times 1 there. So I'm going to change that 1 to a 2. Now instead of having 1 Na, I now have 2 NAs. And so the NAs are now balanced on both sides. And what I'm going to do now is I can check the SO3. Now, SO3 is a polyatomic ion. And one way to know that SO3 is polyatomic is what I can do is I'm going to make a line at the second capital letter. And so the second capital letter would be between this Na and this S right here. So my line would go down here. And then I'm going to check on the right side of this line. And if there are no parentheses, I'm going to put my own like this and put a 1. And that means that I have 1 SO3 like this. Now this trick's going to work every time except for polyatomic ions that are positive. And a classic example of a positive polyatomic ion is something like NH4. So if you ever see NH4, the line would go down at this right here. It would go after this NH4. But we don't have NH4, we have this SO3. And so the line is going to go right here for the SO3, and the line is going to go here for this SO3 here. It also works for atoms that are not polyatomic. So we could put a line down here if we want to. We could put a line down there if we want to. And that just helps keep track of all the positive and negative parts of these ionic bonds. And so what we're going to do is say, okay, we have 1 SO3 here, and then 1 SO3 there. So the SO3s are balanced. I have 1 SO3 here, and then 1 SO3 here. So those are now balanced. And everything in this chemical reaction is balanced. So the answer would be something like this. It would be just like this. This is going to be the answer to this question right in here.